regret. When the lights come down, got an empty crown. My body's missing pieces, can't pull it all together. My body's missing pieces, I wish I could remember. My body's missing pieces, can't pull it all together. My body's missing pieces, I wish I could remember. There's a war inside my head, and I'm drowning in regret. When the lights come down, got an empty crown.
Alright, good morning. It's going to be a relaxing programming stream. I'm going to do a giant amount, I don't think. So what I was mostly just decided to throw the stream on because I was just doing some programming and testing this morning Hold on a minute. Alright. So, I was testing out some neural network stuff this morning. I've been determined to get back propagation working very nicely with the linear rectifier activation function max. So like, just to sum up anyone who doesn't know neural networks, the main reason why people use tanh and like sigmoid and not linear rectifier is because they're differential functions, like completely differential. It has super powerful properties when you're doing back propagation. Basically like the smoothness of the curve. It's really hard to explain, but the smoothness of the curves in it basically make back propagation work properly. The fact that the linear rectifier, except for right at the end, it's actually differential, but right at the end when the linear rectifier hits that end point and it snaps to a flat plane where it's cut off by the max function, yeah, you get, that's where it's non-differential. So I'm still determined to be able to get this working. Like, I don't think it needs to be, numbers are numbers. There's different ways of doing things. So I have right here Learning Machine, which is my current JavaScript neural network library. We're not going to be writing a lot of code like this. This is using fixed points. It doesn't do back propagation. It does train using the output layer, and then it actually uses a genetic algorithm to train all the other layers, the hidden layers. So in this little test, we're just writing a tiny, basically triangle wave test where it has one hidden neuron, one output neuron that's connected to that hidden neuron, and also connected to the input, which basically mirrors the triangle wave. As you can see here, it's almost the same. You can actually represent this. Actually, you can write this as max 0. That, don't even need H there. Just need H here because we need to calculate. So, I wrote this quickly and I actually didn't do the proper neural network training. I forgot that the proper way, like the most effective way to do this is to do normalization like I do here, where I prepare the learning state by dividing by the sum. Normalize it. So yeah, gonna change it to do that here, see how it works. My goal though is to just try and train a single component to start, like maybe have the bias or hidden weight wrong and just have it train those. I'm not sure though. Basically my whole idea is that one of the huge issues with like back propagation here is if you have one little thing wrong, like the hidden bias, it can end up and even though all the other values, the hidden weight and the bias and the weight are right, like very near the maximum solutions values, the solution that it actually will like basically try to solve for the solution that has the wrong bias value here, and then that'll actually train these towards the wrong bias values too. So, basically what I'm saying is if one of these values are wrong and all the other values are right, it'll just completely mess up the other values anyways. So it has some really weird properties where like you can think it's close to the values you're looking for, but it's actually not at all, even if one of the values is off. So my whole normalization kind of fixes this by making sure the derivatives don't explode into multiple neurons, but yeah. So to sum this up, our triangle wave function, this is our target. This is our neural net written explicitly. We're writing all of the instructions by hand. Just main reason of doing this is to test it, make sure we can access everything. the hidden bias, hidden weight, output bias, output weight, precision, which is like the number of samples we're doing in training, the X value from our training, doing 100,000 training iterations. So that's the other thing we're going for, is the main thing, what we're trying to beat here is this fixed point neural network with genetic algorithms, which is honestly so good. Like, this is able to train in like 500 iterations with the genetic algorithm and mixed with the output. So yeah, I don't know if we're gonna beat that, but hopefully. I at least want to try and figure out this math a little bit better. So then this right here is doing the same neural network right here, which is, if you look at these two functions, they're basically very much the same. There's just an extra max function on the end here, as well as and then, like, instead of having the constant multipliers, it's the neural network weights, which we end up wanting to be these values, these constant values that are triangle wave values. So what I need to do, first of all, is we're training the output layer right here on non-normalized values. We need to normalize this derivative by adding up the X and the hidden values. How did I do that? Yeah, I just added up the state. And because the way the neural network works with the linear rectifier, we know all the values are going to be positive, so we can just add it up and it just works. Alright, so then we're going to get the sum of those plus H, OS actually, OSUM. And because this might be 0, I'll check if OS does not equal 0, OS equals 1 divided by OS. Because divide by 0 would have been infinity. So yeah, I don't believe I do that for the bias. Right here though I do OS, yep. And then there we would also, I think, do our learning rate. If I want to do a learning rate, I could do it as this 1 here. So then for this, there's no normalization. This is just the derivative, because X is the only value. Is that right? Yeah, I think that is right. So the one thing this normalization doesn't take into account, though, is backpropagating. I feel like it needs to do, like, to simplify this, I should not worry about training the output layer to begin and just worry about training the hidden layer. Or, actually, since we have this output layer training, let's just train the output layer. So let's give correct derivatives here. Let's see if it'll be able to train this. Oh yeah, so it actually got very close there. Try 1,000. Let's try 100. Is that actually the same? I don't believe that's the same. Maybe it is. Okay, what about 10 iterations? Yeah, there we go. How many iterations does it take to get to that? Wow, okay. That actually trains pretty quickly. I'm pretty happy with that. That actually works basically the same as the other one. Alright. Let me try less learning rate. Try more learning rate. That's interesting. I'm wondering why it's not training completely. I wonder why it's off right there. I wonder if there's something I think times 4 minus 2. No, that's correct. Let me try disabling this bias. Oh my god, the bias breaks it. Oh my god, I'm an idiot. I just rediscovered the... I'm a moron. This is the exact same thing I have here. I don't have biases here because I found that exact same thing out. Yeah, that's oh man. It happens. I did write this thing like a year ago, so... Alright, I'm gonna take away the output bias. We don't actually need it here anyways. Let's see how many iterations this trains in. Nice. Alright, basically 20 iterations. Beautiful. Now I'm curious if I actually do normal. Right here I'm doing a special sampling function where it dithers between one half and the other. I believe it helps a whole bunch. I'm gonna try just doing the regular. Let's see if it works any worse. Oh yeah, it's way worse. Okay. Yep. So, sampling function actually helps a giant amount. So one of the popular way of sampling neural networks is this thing called dropout. Okay, hold on. Holy shit, it's patented by Google. Actual accuracy is disputed. Dropout is a regularization technique patented by Google. Are you joking me? Are you joking me? By preventing complex co-adaptions on training data is a very efficient way of performing model averaging with neural networks. It refers to dropping out units, both hidden and visible. Yep. Wow. I'm actually blown away that something like this that's basically just probability sampling, like it's actually disgusting you can patent something like this. Like, what the fuck? And wasn't this like, yeah, wasn't this an open paper? This was definitely a fucking open paper. You can patent the most abstract shit. My god. Alright. So Google's just trying to own machine learning, I guess, by buying up absolutely everything. I guess that's not really new in the tech world. Alright, now let's do the hard part. Let's try and train the hidden layer. We're going to give it correct output weights. And then we're going to train the hidden now. Stop writing this there. I'm writing this in a text editor because you can accidentally like refresh in Firefox here and all of your text just goes away. Alright, so I'm not gonna train the output. Set these to just blank values of 0 and 1. Alright, so let me see if this is right. I'm actually going to want to backpropagate with normalized values, comparing this weight to the weight of the x value, I believe, instead of multiplying this, then multiplying the derivative by the weight, because I believe multiplying the derivative by the weight doesn't give like the percent. I don't know, maybe this will work. And then here, if we're doing this same normalization, the x is the only input value, so it'll end up normalizing to 1, which means there's no difference here between the bias and the weight. I'm just going to try a learning rate of 1, maybe 2. We'll try this. Doing anything? It doesn't look like it's doing anything. Hold on, let me see what it's training to. I had this console here so that we can go and we can run it in the console and we can look at the output values specifically, what HB and HW are. Oh, that's interesting. So it actually trained the opposite way it's supposed to go. This is supposed to be negative. This is correct, but half the value it's supposed to be. How do I separate the bias and the derivative here? I mean, I'll try multiplying by x. Oh my god, it actually almost worked. Wait a minute, it's working. How many iterations does this take? Yeah, the hidden layer is way slower. So I want to try and get this way quicker. Alright, that's 400 iterations. But that's not training the output either. So the goal of this is to get it to train everything, the output and all. Anyways, I'm still going to try to get this to go faster. Apply this value up. Oh, it got really close there. So that causes overfitting. We'll multiply by half. Is that better or worse than multiplying by the full value? Basically the same. Alright, now what if we do the weights and the bias at a different... We train the bias of the weight faster. Ooh. It actually seems like the, Is that right? Lowering the bias makes it train quicker? No. Kind of, to a degree. So this is the conflicting thing right here. If this is supposed to, mathematically, let's think about this. If the derivative here is going to be basically both positive and negative part way, like at the beginning, this thing ends up basically flat. This ends up being positive here and negative there. So it adds values to the bias and the weight, which explains this, why both the bias and the weight are positive, because it adds to that. But, so that, if, oh man, my goal is to get this in like 40 iterations like this. However, I'm going to do that. Anyways, what I seemingly somehow need to do is get the bias relative to like this x value. Like this is such a weird thing to figure out or compute. But like, I've never really thought about this before, but the bias is a constant value, but it ends up being an offset relative to these input values, which in this case is just x, just an x input value. It's good. So, I believe I should train the bias using something relative to the input, which is the derivative. The derivative is that relative to input, but I kind of feel like I should be doing something like using the derivative to maybe, I don't know. Like the derivative technically should also be giving us a target hidden value. So let me think about it that way. So this derivative should actually, no, it's not should, but ideally derivative should give us the difference between that and the target. Like I said before, I think I should be normalizing that derivative. Or like normalizing part of that value by something, but I don't know. If the output weight 1 is negative, on the left side here, down there, imagine the curve starting out and it's like line going up diagonally like that, ends up being the positive derivative going up, and then that back propagates to the negative weight and ends up being negative, which moves the bias down. I think maybe what I should be trying to do is actually train the bias and the weight separately. Like if I just multiply them by random values, I think is the I have to do like normalized random values, so what I'm going to do is this. No, I think that just made it train slower. Oh, that's interesting. So training the weight more. Oh my god, I definitely think you need to train the weight and the bias separately. Oh my god, hold on. Hold on. What if I train the bias first? No, yeah, you need to train the weight or it's not gonna... And also, is this actually training? Hold on. Let's see if this can actually train the correct bias. Oh my god, it can. But the weight needs to be correct. So I wonder... Can you train this bias first? This. Oh my god, I think this is actually going to work. So train the bias. Go like that. Then we're going to run this again. Oh man, I should be coding this in the edit. Hold on. Alright, so first things first, we're going to train the bias, nothing else here. We're going to do all of this. Just to train the bias. That. Alright, now we're going to go through and we're going to train the hidden weight, which should hopefully be able to be trained. I don't know. It might not work properly. Let's see. I'm just gonna save this down here so we have the full code still. Whenever we want to train the output. Alright, now we'll train the hidden weight. Let me see actually what it trains this bias to. 8.3. That's wrong. Yeah, you know what? I guess you gotta train them at the same time. I feel like there is a way to train the biases though. Like using the position. I don't know. Like, one of the things I believe you could do for these linear functions is you go through and you measure basically the biggest angles or changes, and then you place biases there. Like, I believe that would work. I'm really curious to try that, because that would be like a great alternative to this genetic algorithm where you basically, essentially, intelligently random process of finding it. But if you could just find it by searching through and finding the angles, I think that would be even better. The one thing though that the genetic algorithm always has over basically everything else is it's like throwing spaghetti at the wall. You don't even need to know where the wall is. Like, you just fucking throw it and you just generate genetic. It's like, with this you need training data. You need to know what exactly you want the network to do. With the genetics, even if you don't know exactly what you want it to do, you can just let it try. Alright, thinking about normalizing the derivative somehow, instead of multiplying it by the weight. I feel like multiplying it by the weight isn't the right way. Maybe it is though. If I just took away the multiply x here, they would basically work out to the same thing, right? Okay, guess the one is bigger. I want to like focus in where there's more error. So one of the theories I have, what if I did like derivative times derivative? So it was, that would only work if this is clamped to 1 though. Otherwise it could be way bigger. I could also like average the derivatives and then normalizing that wouldn't be good. Yeah, how do I push this bias negative while pushing the weight positive? What if I just did like relative to the bias itself? That seems really stupid, but let's try it. Oh my god, it actually went negative. Holy shit, that actually worked. Hold on. Oh, interesting. Interesting. Ooh, very cool. So it actually trains that part, but it doesn't train the trains the bias correctly, I think. No, it trains the weight correctly, but not the bias. Yeah, negative 336. Okay. Alright. Maybe HD minus X. At this point, I'm just like trying a bunch of stuff, seeing what works, because I don't know. Okay, so this does work, but it doesn't work fast enough. How do I make it work faster? I could try normalizing this derivative, like I said. Because these values are constant, I think that would just be a constant. Divided by that. No, that slowed it down. So if anything, I need something that actually increases it. Probably something that actually increases the weight here. Okay, I think I understand. I need to kind of do the normalization step here of how it the normalization essentially calculates, ends up giving you the percentages of how much each neuron contributes. So we actually need to do this through to the hidden layer. I'm not completely sure. But I believe we need to calculate how much this contributes. How we multiply by x here. OS. Maybe actually backpropagate this value to x times OS. No, that made it way worse. Ooh, that was close. Still doesn't work amazing. Let's just try adding this training to it. It's basically the same. Yeah, so training the output layer breaks it. Yeah, oh my god, this sucks. It was basically the same conclusion I found before, is that the linear functions, you cannot train it effectively. Or I believe you have to actually do what I was doing, where you train either the output or hidden layer first, or each one by one. Bring up I believe I have an example here. Oh, doesn't have the file available. Oops. Okay. Never mind. How would I improve the training here? Just to try drop out. No, it's not learning the biases at all. Oh, we got it right there. Doing here, that's doing so well. Interesting, it gets stuck though. There we go, that nearly trains. I think I'll switch over to daily shader art in a second. I just want to see if there's anything else I can do here. I mean, yeah, it's nice that it kind of works, but that's not what I'm going for. It kind of works. I'm going for very optimized. Yeah, well, I guess that's that. Alright. Now for the fun part. Oh yeah, let me bring up the rendering from yesterday. Ooh, I still haven't. Oh. I haven't added my other YouTube account. Hold on. There we go. Okay, here we go. Jesus Christ. I hate all the YouTube suggestions and things. I need to figure out how to turn this shit off or something. Alright, anyways, this is it. Those super circle rendered out. Pretty happy with it. It's not. It didn't turn out as bad as I thought. What the fuck is up with that auto-playing video of US law? Anyways, gonna make a new one today. I'm just opening up Shader View, the program I use to make these. Alright, hold on. I'm just gonna go get some water and we'll begin. Actually, you know what? Let me set up a base scene first. Let me like delete the stuff we have here. I'm not sure what I'm gonna do. But we'll do something. Just deleting all the stuff from the old shader here. Alright, there we go. I'll be right back. Actually, wait, is the music still going? Oh, the music stopped. Of course it did, YouTube. Alright, I'll be right back. Alright. Okay. What to do today? So we got transparency and all that working. I was thinking of almost doing like a tower type deal, like how we did I did the sphere the other day with a bunch of holes in it, like a tower with a bunch of holes in it like windows. I was also thinking of trying to do actual, like, terrain today. There's like a planet with a hole in the center of it. Yeah, maybe I'll just try to make terrain to begin. So I did something before with like repeating spheres to create like bumps and indents. I'm almost thinking of doing something like that, because the distance field isn't broken when you do that. Or I could just do good old deformation. Okay, that actually works. Worked. It made hills. Huh. Alright, so now I'm just making different frequency sine waves to this plane to hopefully add a look of like bumpiness. Yeah, so it doesn't really get much shading with this. That's better, but I think I'm gonna take away the sun for this. Yeah, you can actually see the bit of shading way easier now. Alright, I'm gonna try adding the biggest bumps first. Now those are so far away you can't even really see them. There we go. So now it's starting to actually glitch and break in places. I don't know what that is. I don't know if that's not a number. I think it might be. The normal ends up being 0. Right here, I think. No, I don't like doing this either because it's a deformed distance field. I'm really trying to stick to stuff that has a proper distance field. But I think I might go with the sphere technique. So with that I create an array of spheres with different heights. What I'm almost wondering of doing though is doing something with like smooth min. Let's go with smooth min here, yeah. Okay. So I'm gonna try something combining grids of spheres. The way this is gonna work, it's gonna check and do random spheres with probabilities of occurring lower down, so it's to create interesting structures. So I'm going to get the floored position. This is going to be our coordinate that we use for the random sampling. And so I'm gonna do a technique here. What I used to do is I used to loop around to the surrounding tiles, randomly generated tiles, and get the distance there. But instead with this, I'm gonna try to do I'm gonna leave a gap of space between each tile that hopefully is enough that stops the distance function from over jumping or causing the ray to over jump. So then I can just do multiple arrays to fill in the space. Another thing I am thinking of doing though is I'm thinking of doing a deformed one. I'm thinking of doing like a twisted grass plane moving around. I don't know. Yeah, maybe I will try that. I'm gonna try doing, so basically what I'm talking about is where, like, it basically curves along your view, like twists. Hard to explain. But anyways, I need a pattern like this to begin. I'm gonna try to do something like grass. A really high frequency sine wave to simulate grass. Yeah, that's actually too even pattern. Add a little bit of a shift right here. The values change. That's still basically noticeable. Let's see what happens the more I shift this upward. Yeah, it gets more noisy. I'm actually curious, if you render this out, does it end up looking like anything? Hold on, I'm going to do a very small window. I should have rendered, I don't know. Yeah, what is happening? Why isn't that rendering? That in there. There we go. Yeah, so the sine wave distortions 100% cause errors. You know what one of my goals is, I think? I want to try and make a path tracer that just deals with any issues. It's probably going to be super inefficient, but create one that just deals with any errors in the distance function. So you can basically just like throw a distorted distance function whenever at it, and it'll work through it. I don't know how that would work though. Besides just like doing non-distance marking where you just step a tiny bit and check. That's what you end up having to do for a bunch of fractals, so yeah. Alright, well, I think I'm going to actually try to simulate the grass with little spheres then. Alright, let me see. Are these so small that you can't see them? Happening. Yeah, there we go. Now, what is that? There's almost like a line on the top of them. I don't know if that's the epsilon. Yeah, that's the epsilon. Okay. Now I want to see if I stretch out the y here. Not as good. I'll leave it as circles, spheres. I'm just thinking what I can do besides spheres. I could do cylinders. Although I think this will have good enough of an effect. think that's caused by an issue with the epsilon. No. Alright, now we're gonna add a curve. So this is gonna like wrap around. So the way we're gonna do that is we're gonna distort space using the rotation function here. E.xy, yeah, I think it's distorting along xy is what I do here, and then do it along the z. Basically it rotates it as it goes along the z. Yeah, and you get this crazy effect where the world wraps around. I actually think I want less iterations so it kind of opens up there. Now, it's hard to tell, but it seems to be breaking these when it flips around. Not sure why specifically that's happening. What if I make this flip faster? Yeah, and now you can't see what's going on because like no light gets in there. There we go, I think that works doing length E. Oh god though. Yeah, if the normals are broken, then that breaks this part, the path tracer. Hold on, I'm gonna fix that. I think I can fix that here. I think if the normal is broken, then we can just straight up add this. No, I guess it's maybe not the normal then. Maybe it's legitimately the value here becoming not a number. See, I don't think so, because then that would have a bunch of black pixels too. And it doesn't. So it's something right here. If there's the dot. Oh, I need to check OM normal as well. Oh, okay. And then here, we can just check if this normal isn't good. We can just set it to 0 or something. If we set it to a really high value, it'll probably almost always end up being... No! Oh, what are these? What are these? Maybe it's that divided by 0? No. Let me output red here, just to test and see if it's ever triggering this. No, it's not. So what is wrong with the normals then here? Probably actually not a number. No, it's not that. They're not. I'm pretty sure that's how you check for non-number in Infinity. Maybe there's an is infinity or is not a number. Oh, there is not a number and is infinity. There we go. See, this shouldn't be not a number though, because it's coming from warning, scalar, Boolean expression, expected. Oh, this returns an array. Huh. This could be happening when it renormalizes here if this ends up being 0. Why is that outputting black? Does not normalizing this really break stuff that badly? I guess so. I wonder if you have to do this for infinite values too. Hold on, let me look at let me zoom in on these pixels, let me see if there's actually anything going on in here that I just don't see. So I'm assuming that's the background bleeding through. So that's where it's returning background right here. And then wherever it runs, this is ending up completely black for some reason. I honestly have no idea why. If I had to guess, if I take out this, you know what, I haven't even checked if it's actually the normals. Let me take out the normal operation. Oh my god, it's there even without the normal calculation. Hold on, what? Does that mean it's something to do with this? Wait, what? Actually, what the hell? I guess. Yeah, I don't know what is going on here. But these are ending up black. Try taking away parts of Is that an overflow? Is that infinity? It's really hard to tell. You can see it's going to complete green there. Yeah, it's definitely overflowing. Huh. But that must mean that it's like overflowing here in one of the first path tracing parts. So, okay, what if I check for this being not a number? Yep, it's not a number. Okay, Question is though, why is this ending up being not a number? I wonder if the color value here is ending up above 0. Let me check this. Oh my god, this is turning more into a ray tracing debugging stream than actually creating anything. I guess that is creation. So what I'm going to do is I'm going to go to right here where it renders the lighting. I'm just going to have an output the material color. -1 and then scaled up. So what this should do is that if it actually is above 1, it should show us. Very interesting. Very interesting. It's, that's not the background right there, is it? Hold on, let me turn off background rendering. Yeah, that was the background. Okay. Yeah, so there's no materials that are above 1. Doesn't make sense then. So our S value here starts out at 1. And then it's multiplied by the color. And at the end it multiplies that by the lighting. Unless there's emission. Okay, let me check if it's outputting emission for whatever reason. No? Huh. Okay. I honestly don't know. What if emission is negative? No? Huh. What if emission is not a number? Nope. Wow. Yeah, so I have no idea what's going wrong here. If I had to guess, the normal values are wrong. But I still don't see why that should result in what it results in. Or why it should result in light being not a number. Oh my god, I'm a fucking moron. Oh wait. No, never mind, I'm wrong about that. Oh, it's because I didn't set light, but how? What is wrong here? I'm actually so confused. It starts out with 0. It must be the texel here ends up being not a number. And I guess somehow like pollutes. So what if I just do TS? Just TS. It's only added if it's not a number. Oh, okay, that fixed it. I still don't understand why this is not a number sometimes. I wonder what it's outputting here. I wonder if maybe it's outputting the background and it's just not registering it. Either way, whatever. That is fixed. Alright. Let me try to get this distortion looking alright. Go back to what we were originally working on. So I want it to wrap around fairly quickly. Hard to explain because I still want the sun to get in, if that makes sense. But if it wraps around, it doesn't really. Kind of like a shell.
Give or take, I'll be the best, no doubt.
I guess it's actually like a wave.
As the baseline takes control.
Just thinking how I could actually make this. I think maybe clamping this might be what I want. Yeah. Yeah, there we go. Those artifacts, but I think we can fix that. Maybe an increased epsilon would help there. And then the idea is to make these grass things move. Alright, now I want to try and fix that up there. So what I'm going to do is lower the distance function as it gets higher up there, because that's where it deforms more. Alright, there we go. This is like a weird type of wave. Now what if I put the bright sunlight in here? Might be too bright, I'm not sure. I'm also not quite set on this color. I think of anything, I'm just going to make the background brighter. I'm still not quite sure on colors and things for this. Alright, let's see what this looks like. A few more samples. Oh, I forgot to update it. There we go, much nicer. Hold on, I'm gonna stand up and take a quick break. I'm also gonna think of a name for this. This is always the hardest part for me. this is kind of what I was going for. I think I'm gonna, I feel like I should change up like the distance of these things. I have some stuff to think about this. Hold on, I'm just gonna get up and stretch. Be right back. Okay, I figured it out now. I'm gonna try applying smooth min here to smooth out these. And maybe add a little bit to their size. Bigger. And a little bit more separated. There we go. That looks pretty cool. Wow, look at that. Like that up there is the reflection back. No, it's the epsilon breaking. That's pretty cool. Go with that. It's weird though how the reflections on here look, but I think they're correct. Yeah, like those don't look like they're changing with the roughness. Oh my god, I think this is checking the wrong thing. I was supposed to check surf. It's the opposite direction of normal. Oh wait, no. This is correct. It's checking whether or not this separate direction from the surface. Where's this? Oh yeah, they actually are. That's so weird. So I guess this ends up being true every time. I might just remove that then, if it actually doesn't work. I wonder why it doesn't work here. What if I try setting this to direct reflection instead? Not much of a change. That changed it though. I think the normal ends up being wrong right here. Or maybe the upright vectors. Hold on, I'll just try increasing the view distance massively. Because it could be it's just not reaching the view. No, it's not that. Guess it never reaches light there. There we go. I like that with that bit of rough reflection. Make the light brighter though. Alright, there we go. Maybe we call it like wave wall or something. Maybe calloused curl. Weird name, but it works. Alright, there's our shader for today. If you have any questions about any of the code here, I'm always on Discord. This program is available for download on my website. the links for that all over. I actually just uploaded the video just yesterday. Shader View, a little app I made. You can download this off my website to show you showing how to get Shader Viewer 60x2 frame. Showing how you can render videos using it. How I use it to do these renderings and things, if you're interested in that. How the fuck do I hide YouTube up next? That's what I gotta do. That's what I gotta do right now. How to hide YouTube next suggestions. Anyways, the rendering of this, the 4K rendering of this will probably be up at the end of today. That other YouTube channel, Ethan's Renderings. If you're interested in that. Other than that, have a good day. I'll see you around. Hope you enjoyed the stream. I'm gonna be trying to get back in the rhythm of doing these programming streams. So I haven't really been doing that much. So I'll see you around. Thank you for watching.